Hello, everyone, and thanks for joining today's live demo. My name is Amy Bui-Perez with Emphasis Stelligent, and I will be your demo host today. Before we dive into the presentation, I'm going to cover just a little bit of housekeeping. This demo is being recorded and an on-demand link will be available and shared with you post-demo. Please feel free to share this link with your colleagues. You can submit any questions you may have in the Q&A box in the lower right-hand corner. We will spend some time at the end of the demo to answer your questions. If we do not get to your question today, don't worry. We are happy to follow via email. And last but not least, if you are on Twitter or LinkedIn, please be sure to follow Stelligent for news, resources, and announcements. Today, we have Richard, who will be conducting a live demo for us to showcase Topograph. Richard is our principal tech lead here at Emphasis Stelligent. He leads the cloud innovation and transformation team. A polyglot driven by passion, he has developed dozens of products and platforms over the last 15 years, being considered an expert by his peers in the DevOps, full stack development, serverless, and cloud architecture. In recent years, he has shifted his focus towards data analytics and ML, applying predictive modeling, NLP, and classification models to DevOps, Agile, and cloud data. At this time, I'd like to go ahead and hand the mic over to Richard.
Wow, thanks for that introduction, Amy. That was quite a mouthful there on my experience. Appreciate it. Yeah, so today we're going to be talking about Topograph. So a little background, and we'll get into what that is in a minute here. But Stelligent's been in the DevOps space for 15 years, before the word DevOps was even a buzzword. We became an AWS partner in 2009. We've worked with dozens, maybe even 100 different large enterprises that are going through DevOps transformations, Agile transformations, specifically as they're moving to AWS and some of the other clouds. So from this experience, when we were talking to our customers and watching them go through these growing pains, we identified a lot of different challenges that they faced, as well as some ad hoc processes they developed, and custom dashboards and data aggregation strategies, right? So the three really major challenges that we've seen with some of our clients is developer productivity, which we also call organizational agility, DevOps maturity, and then analytics and compliance. And this is what Topograph is really attempting to solve, is to help you better understand how your organization is operating from an Agile perspective. We have the tools that are Agile, but then the process of actually moving quickly and reducing technical debt, things of this nature. How do we actually do that in practicality? Specifically, we talk about Agile is hard to measure. It's a very qualitative process where you have a bunch of different team leads who are coming up with their own understanding of what a user story point is for different frameworks and technologies. So how do we ultimately understand and compare different teams? How do we understand the difference between productivity and effort? Looking at the amount of code that's being written versus the amount of code that's actually going into production, where the different issues and bugs are coming from, how do we reduce technical debt at all the different layers of the organization, as well as ultimately reduce some of those performance issues, manual handoffs, and expensive refactoring that's top of mind for all IT and DevOps leaders. The next one is DevOps maturity. So as we're talking to these companies that are putting in new tools and technologies, new tool chains, maybe they're going from on-prem to the cloud and taking advantage of some of the cloud native features and services, there's a limited visibility. We're talking about companies that have 10,000 different applications. They've got 1,000 different tools, understanding and clustering these different applications together, understanding who their leaders and laggers are from a DORA perspective, right? Finding the different bottlenecks and where the automation is limited, kind of coming up with that proper balance between empowering your teams and tool sprawl, right? So what we do is we go out and we gather a huge amount of information from the actual repos and from some of the different DevOps tools, and we'll be getting into what exactly that data looks like later here. And the final one is analytics and compliance. So we kept hearing over and over again that there's this gap between IT and business as they are trying to steer into this new space that is DevOps in the cloud, right? Siloed data and proxy metrics is ultimately the underlying issue here, and just lack of metrics in general. So, right, it becomes very difficult tracking and enforcing different policies, comparing those different teams against each other, even just getting the data, aggregating the data from all of these different teams to understand at both the business unit, the product, and the organizational level how things are operating. Another trend that we've seen with businesses is as they go through this transformation, they have a cost center perspective, right? So they're trying to reduce costs, but ultimately a lot of the time this ends up reducing value as well. So understanding both the value that's being delivered to the organization as well as reducing costs and finding this really healthy balance that's going to make your organization thrive in this new agile age that we've gone into here. So what does this mean? I just talked a lot about agility and DevOps maturity and data. Now we're going to talk at a very high level about what Topograph looks like and how we achieve this. So we integrate, if we look over here on the right-hand side, we integrate to a handful of different systems, right? We integrate to the CI/CD. This could be Jenkins, Azure DevOps, Code Pipeline, it could be Travis CI. And from that, we're pulling all of the build data. We integrate to your version control data. This could be GitHub, GitLab. From there, we can see all of the different files. We can see the tools and technologies. We integrate to your Agile data. It could be Jira, Asana, right? We've got about a dozen different integrators. More than that actually at this point. And then we integrate to the cloud data as well, where we pull things like tags and we can look at availability. Ultimately, all of this data is correlated and cross-referenced against each other. And we come up with a handful of different KPIs and metrics, some of which are related to the development velocity, some are related to DevOps maturity. We do some risk identification with our static analysis microservice. There's some delivery quality and some value stream mapping where we aggregate the data from across all of these different teams or business units in order to pop out some time series metrics that help steer the business. So what's the key pillars here? It's visibility, right? Just having access to the data, aggregating that time series data from all of these different systems, and then being able to correlate it against each other so we can come up with some rich analytics. The next one is identifying bottlenecks. So once we have the different tool chains, we understand which repos, which products are using which tools and how they're performing from a DORA standpoint. We can then go through, identify those leaders and those laggers, as well as the bottlenecks in the process there. The next one is actionable insights. So once I actually know what the bottlenecks are, what do I do? And the final one here is the reduction of risk. So we're looking for these DevOps errors and warnings, as well as the application errors and warnings over time. And we can surface all of that information so your organization can operate in a more secure manner. So just taking a little bit of a step back here to make sure everyone gets a refresher on DORA and Accelerate. Every year, DORA and Google release an Accelerate report where they go out and they essentially send out a survey to tens of thousands of different companies that are performing software development and delivery. Right. So what they do is they're asking about specifically the lead time, the deployment frequency, the change fail rates, the time to restore, and the availability. These are the Availability is new. It used to be the 4 key metrics. They still call it the 4 key metrics, but they added availability recently. All in all, in DORA, though, there's probably about 20 different metrics. But when you come and you look at the literature and you read a high-level white paper, these are the 5 that they're going to hit on. All right, so the lead time is from when a user story is crafted to that feature makes it into production. The deployment frequency is how often are they deploying and pushing code to production. The change fail is how often that pipeline fails as it's going to production. And the time to restore is if an issue is identified, how long does it take to resolve that issue? And the availability is fairly evident, right? It's the percentage of the time that the application is available. So they have 4 different classes that they break different companies into, and it's not about what class you're currently in, but it's about understanding how to improve your organization from a DevOps perspective so that your company can become more agile and deliver value to your customers or internally faster and at a lower cost. So for example, the deployment frequency, we'll see some of the low performers releasing software every 6 months in a hybrid agile waterfall type of model, whereas the elite performers are releasing software on demand, which means that they can potentially be releasing a piece of software, an application, a microservice multiple times per day with these very small iterative changes where the team is reviewing the code and they have a whole suite of different testing and static analysis, potentially some canary or blue-green deployments. So it's a fully automated process from the check-in of code to the deployment there. Yeah, and then next we also want to level set on our view of productivity, right? So it all starts with the culture. Ultimately, yes, we want an amazing product, but it starts with the people. So we need to be thinking about how do we reduce burnout? You're going to have coders that are all-star, they want to come in, they want to change the organization. And if you don't put in place the proper kind of nurturing and support, a burnout can occur for all different types of developers there, right? So as we're looking through the different code, we also want to understand the maturity level of those developers in terms of how do we mentor and develop them more effectively, and put in place the feedback loop for continuous improvement. And it's great to really have and embrace the failure and learn from it, kind of feeling within the teams as you're moving forward. Next, we like to talk about the effort. So here we're looking at lines of code. We're looking at the frequency, we're looking at the quantity of the code contributions, we're looking for duplicate code, right? And we're also removing auto-generated things like the package JSON lock file, right? So it's getting just a very basic understanding of new lines of code that are being written, which we call effort. From this, we look at the period over period. So this is a great way to see if there's burnout or excitement within a team or for the individual developer. From here, we also look at things like stale branches, right? So there's this huge amount of effort. Did it actually result to new features, making it into production? And of course, in order to do all of this, we have to have a PR and commit visibility. Next, we talk about the churn. There's a lot of software tools out there right now that are talking about file churn. We go a level deeper and we actually do line churn. I'll be showing this feature at the end here, which is called user contribution tracing. We're one of the only tools, if not the only tool, that can actually go through and track a line of code and the history of that line of code on a change by change basis over the entire course of the project. From that, you can go backwards and see how many times a different developer touched that line of code and who ultimately got the working line into production. It's pretty interesting. Developer maturity. From the churn, you can get a sense of the developer maturity, right? A more mature developer is probably going to get it right on 1 or 2 passes, Whereas a developer that's maybe learning or expanding into a new area in that continuous improvement mode might take 4 or 5, 6 tries even. It's a little bit like golfing. So the next one is analyzing the mistakes, right? So we can constantly improve, and helping to align the teams, right? So here's someone who's excited. We're seeing a lot of effort come out of them. They need a little bit more mentoring. This person really excels in this area of code. This person's still learning in this area. How do we align these teams to be most effective? Of course, next is quality, where we're tracing bugs. From both a perspective of fails in the pipeline and from static analysis and linter tools. We do a feature versus debt reduction versus bug detection. There's some code complexity, cyclomatic, and cognitive complexity that we're building into the tool. And then I already mentioned those DevOps applications, errors and warnings. And ultimately, of course, the goal here is the release. So successful code deployments, new features being delivered to our clients and our customers, reducing the recovery, reducing the downtime and increasing the recovery speed, putting in place more effective code reviews, and having agile best practices that are really going to fuel the organization. So just one last slide here before we get into the demo. I want to set the expectations on what you're going to see here before we dive right in. So we have a handful of different microservices that crawl the data. We also have a great backend and a front end with React, right? But here we're looking at where the data is coming from, how's it connected, how do we put together all of these great metrics and KPIs. So from the Agile perspective, what we're doing is we're looking at the user stories, we're looking at the issues. Those are correlated back to the commits themselves, right? And we can see all sorts of interesting things like open, close, burn down. We can come up with things like project management debt from changed user stories. For the CI/CD, this is where the majority of those DORA calculations come from, right? So for almost all the DORA calculations, you have to identify when there was a fail in the pipeline or the time between a series of fails and passes. And then also for the lead time, you correlate that back to the Agile data. And then the heavy hitter of the group is the Git crawler. With the Git crawler, we go through every single commit, we go through every single PR. We're looking at what we call key event detection. It's we have both a trunk-based and a branch-based algorithm for how we look at the data. From those commits, we actually go through every single diff and every single file. So there's a lot of processing going on here, right? For the files, we go through, we categorize all the files, we tokenize them. That's how we determine what tools there are. We've got some YAML configuration where we can do more complex strings in terms of various application compliance. And then we do something called context filtering, where we go through and we take all of these different data points that we found and we can assign them to a maturity score, a couple of different maturity scores, in order to better understand how those products are operating from a DevOps standpoint. And all of that is customizable. So the next one is the commit diff analyzer. We go through every commit. We look at the additions and the deletions. From there, we have some algorithms that determine if it's a feature or if it's a debt reduction or a debug effort. From this, we also do that user contribution tracing that I was talking about. And then over on the far left here, we've got the code quality and quantity assessment. There's two different facets of this. One is going through those files and removing the auto-generated files. We use an open source package, which can find all of the different comments in the application code. And then we do some code density calculations, where we look at the length of the line of code, the number of spaces, We can compress the variables so we can get a more accurate sense of the code density there, looking at the operators and operands, things of this nature. And the final one is the quality assessment there. So we have a microservice that has a bunch of different stack analysis and linter tools in there. Essentially, when it detects a DevOps file, it sends that file over and it will run the quality or the security tool on it. And it'll also send over all of the different application files. For example, with Node, it'll run ESLint. With Python, it runs Prospector. And this is different than SonarQube in the fact that you don't have to go in and add a trigger to every pipeline. We can go out and pull all of the data from all of your products historically, right? And trace these vulnerabilities, errors, and warnings back as far as you want to go. So it's a pretty push button approach. Okay. All right. So let's sign on into Topograph. So I'm going to start off looking at the project management view, which is primarily focused on the version control data. Actually, let me take a step back here and explain where all of this data is coming from. So we've got, in this demo environment, we've got 3 different product teams. I don't want anyone to be confused. We pulled all this data from GitHub. It's all open source data, it's real. So our 3 teams here, though, are Microsoft, Google, and HashiCorp. So we've got some sort of mega, in this scenario, we're some sort of mega conglomerate trillion-dollar company, which would be very fun, you know, but and then each one of these different business units, we've had a couple of their repos here, right? Now, the tool is designed so that we can compare these different teams against each other, as well as see the value streams across all of this data. And this is going to become more apparent as we move through the demo here. So going over to the project management view, you can see we've got our different teams here. At the top, we've got some high-level metadata. We've got the applications, the total number of users that have touched all of this code, the pull request over the course of the period. So up here, you can pick the period that you want to look at, and the number of associated commits there. So we see that this one's got 2 pull requests. The last merge was 55 days ago. We click on it. At the very top, we see some high-level velocity metrics, the number of commits over the last year, the average lines from those commits, the average commits per day, and the average lines per day. For the overview, we've got the DevOps maturity. We'll show you how that's calculated, and that last merge 55 days ago. And of course, with this is all the configuration for this is in YAML files on the back end. So if you want your stale repo to be 3 months, we can set it there. You know, if you want it to be 3 days, that's an option as well. We scroll down a little bit, and this is our effort from the developers, right? We are looking at the lines of code that each one of these developers have touched. You can break it down into additional groups if you've got more than about 15 developers on the team to make it a little bit easier to read. But what we do is we remove all of those auto-generated files. We look for things like renaming files, right? So with the tools that are out there, sometimes you'll see a developer that did 100,000 lines of code over the course of a month. And we all know that's not possible, right? So we've developed these different filtering processes so we can actually get to what is the real number of lines of new code that the developers have written during this time period. We scroll down a little bit further, and we can see the features, the depth, the debug, and the defect efforts in terms of lines of code over the course of this period, right? So 55% of the effort has been new features, 28% has been debt reduction, a pretty high percentage of debugging here at 9.1%. And then we go down a little bit further, and what we have is all the different PRs that are associated to this for the last year. So we'll click in. At the very top, we can see the DevOps maturity score. We can see some high-level files changed, additions and deletions. Here is the comments, right? So we go through all that different application code. We determine what percentage of its comments. We have the code density score. We've got the average lines there. Scrolling down a little bit further, we've got our two different categories of files we're looking at. So this is all the files in the commit. We've got the category, the file type. You can see there's some omits, there's some NAs. This allows us to do more granular processing of the different files. We've got the space percentage, we've got the file lines, the characters per line for the code density score. We've got the comments, and then over on the very far right here, we've got the tokens. I'll show you how we use those in a minute. And the other function here is from the commit diff itself, where we're looking at, hey, these are the files that were modified. Was it an addition? Was it a deletion? Was it a rename, etc. So if we scroll down a little bit further, we can see how our DevOps maturity score is calculated. Right, so the tokens from the application filter down into these different areas. And we can find, hey, they've got Docker, they've got GitHub, they've got Docker Compose, they've got Git. From a CI/CD perspective, they've got a build stage, they've got unit test. And that's how those DevOps maturity scores are calculated. And we'll look at some maybe that of a little bit higher score here in a minute too. Next, we have the different linter events. So it identified a Docker file and it sent it over to HatoLint. And it also identified that this was a Python repo, so it ran Prospector across the entire application files there. And then the summary of those are in bright red and yellow right here as well. And then at the bottom, we've got the different commits. So let's go back and actually quickly take a look at another repo. I think we've got time. Okay, so with this one, you can see there's really just been one code contributor over the last year, and all of that happened in June. It's kind of interesting. Let's go on and see what else we got. Okay, just a couple of linters running. It's a little bit higher automation score. Interesting. All right. So how do we take this data and compare the different applications? We're going to jump over to the dashboard. This is the tool chain analysis, the CI/CD analysis, and then the quality scores. All right. So from here, we can see side by side which products are running which tools. So we've got Vagrant installers down here, for example, which is a make file, bash file, Vagrant, rake packer, a lot of different DevOps assets. Yeah, and a lot of these are a little bit kind of more straightforward, just in terms of having a bash and a make and a Docker. We scroll down a little bit and we see the CI/CD. So a lot of Python repos here. We identified there's a build stage where they're using unit tests. Some are using PyTest, some are using PyLint. Some of them are using that before script there. And something that we can do is we can actually take this data and then use it for application compliance as well. So here at Topograph, we know every company has their own challenges. We definitely have the data. We've got a fantastic framework here in place, and we're always looking for new and exciting challenges to kind of take this data, reshape it, get some new UIs, and help solve your problems. And then the last one down here is the quality aggregation. Let's see if we can find one that's a little bit troublesome. Okay, so here we've got the voice builder. They've got 45 application errors, 10 DevOps errors. Of course, we can sort these with a leaderboard or a lagger board. So you can kind of go through and figure out which products and repos need the most attention. Yeah, so we'll go through a couple of these other ones. And in this environment, we do have a little bit limited kind of CI/CD data, considering they're open source and we don't have access to those pipelines. But we've got the pipeline lead time, the deployment frequency, the MTTR, the fail frequency. In terms of the other metrics that we're looking at, we have a value stream where we go through and we gather all of the different metrics in time series. So as you can see, we've got the last 4 years here. We've got the debt, we've got the debug, we've got the feature efforts from the last 4 years. And here we can do some interesting things like say, hey, we've been tracing the pipeline maturity across the organization. We've been tracing and tracking the testing initiatives across the organization. How are those actually impacting my core DORA metrics? How is that impacting the agile and the base velocity across the organization? Next, we go down to the scorecard. So as we were talking to C-levels and VPs, we got this request, hey, I want a screen where I can come in once a week and just very quickly look at my different groups of data and understand where I am at this week. So we created this scorecard here, which sums together all of those KPIs, ratings, and so you can quickly come in and understand on that weekly or monthly basis. And then the final screen I'm going to show you, or one of the final screens, is the metrics here. So the value stream and the scorecard, we're looking at the entire set of data, and then you can come down to metrics and you can compare those different teams against each other. And some really interesting stories here actually start to tell themselves. So we can look at the comment percentage of our different code bases. And what we find is that Google was doing a fantastic job of commenting up until 2020. Who knows what happened there? As you can see, HashiCorp is almost identical at 3.5 across all of those different years, which is interesting. And then Microsoft is, they are getting better and better year over year, which is fantastic. The commit count per each one of these teams, and the size might be a little bit more interesting. So both HashiCorp and Microsoft, they're iterating more rapidly. They have smaller PRs, less lines of code, and what we'd expect is to also see some shifts in those other agile metrics, such as the commit frequency and the duration as well. So the one last feature I want to show before we hop back into the presentation, take some questions, is the user contribution tracing, which I've mentioned a couple of times. And essentially, oh boy, I'm logged out. Okay. All right. Okay. Let's go back real quick here. All right, so we go in and here's a file, and we're looking at the most recent commit, right? So on each line of code, we can actually see which developers made that modification and the total history of each line of code. This is pretty wild, and I don't think anyone else has this. So here's the first commit. We've got this R character. I'm not sure who that is, but as we move forward, you can see so there's a lot of changes. As I'm looking at this, I'm thinking maybe this R character hadn't done React in a few years, or maybe he was ramping up. And then an S character comes in and makes a lot of different modifications. And it really tells a story here about the developers and the contributions that they're making. So huge amount of potential with the user contribution tracing. We're very excited as we move forward to tie that back to some of the agile stories for bug tracing. All right, so back to the presentation. So what does all of this mean? You've got all of this great data. How's it actually going to impact your business? And we like to talk about the 3M transformation. So at 3M, we've been working with them for years now. They're one of our favorite clients. And essentially, we've taken a couple of the big wins here, is we've taken their cycle time down from 276 minutes to 4 minutes. There's been a reduction in pipeline failures of 50%. And the application onboarding time has gone down to a single hour, right? So having the data, having the metrics, that visibility, the observability, and then putting the proper initiatives in place, it does pay off. Back in a percent here. Yeah, and then before we take a couple of questions, I'm just going to talk about the implementation steps. So we've designed this to be an extremely minimal footprint. It's a single cloud formation or Terraform template, depending on what cloud you're going into. The entire deployment process takes about 20 minutes. It's all least privilege with IAM or whatever's being used for the user policies there. We use KMS, we use encryption, SSL, all of that good stuff. From the clients themselves, all we need is a couple of read-only keys for the different DevOps tools to get the crawlers going. And if everything goes according to plan, we can have these out-of-the-box reports ready for you within a couple of days. It does start with some project planning, though. We go over to the engagement steps. So we always like to meet with people and find out what tools they're using, what exactly they're trying to achieve. A lot of times there are some unique processes in place which might require some customization, and we want to make sure that we have those integrators too, so that we get some good value right out of the gate there. For the implementation, we've got a couple of different approaches here, but kind of the most minimalistic, it's just a couple of those infrastructures code templates, as I mentioned. We'll start off potentially with just a few key repos so you can get comfortable with the tool and what the output looks like before we scale up. And the tool is extremely scalable, right? So everything is microservices. For smaller implementations, we'll do Docker Swarm on a single large instance. And for larger enterprises, we do have a Kubernetes deployment where we can go out and scan thousands of products and repos, right? So a bunch of different, the whole gambit of kind of different companies we can support there. And then the last one's customization. So there's a lot of great features that come out of the box. Every client, though, has some kind of new features or new data they want to get their hands on. We're always iterating. We've been working on the product now for a little bit over 6 months. Every month we release a new UI or a new major feature, right? So it's a pretty exciting time. And, there might be a special algorithm or UI that you're looking for. So we're happy to understand, have those conversations and better understand what we can do to help support and fuel your DevOps transformation. All right, so on that note, let's take some questions.
All righty. Thank you, Richard, for that great demo. As we wait for some questions to come in, I do want to take this time to remind you that questions can be posted in the Q&A box in the lower right-hand corner, and I will read them off as they come in. Looks like we do have a couple of questions here for you, Richard. First question is Topograph multi-cloud?
Yeah, great question, Amy. So we currently support AWS, of course, Azure, GCP, and yes, even Oracle Cloud. So lots of different options there. We say it's a fully agnostic tool, right? So we can deploy to any cloud and we can potentially integrate to any tools that you're running.
Alrighty, thank you for that. Second question is, can it be used for both legacy and new pipelines?
Yeah, that's a question we get on a pretty regular basis. And yeah, of course, it can be run on any type of pipeline that's codified, right? Well, there's two aspects to this. One, we actually hook up to the APIs of the pipeline there. Then two, we look at those pipeline files as well. So yes, we can hook up to all different types of pipeline, both legacy and new.
Great, thanks for that. Next question is, how long does it typically take to implement Topograph?
Well, yeah. So as I mentioned before, it takes about 20 minutes to install it, but then depending on the level of customization you're looking for, normally we do a contract, just a service contract that's anywhere from 3 to 4 months, right? So we like to spend a month where we come in and we deploy the solution. We start doing some base crawls. We show the value to the organization, right? We figure out what those customization steps are. And then we spend 2 or 3 months building out some new APIs, maybe building some new integrators, building some UIs that are really fine-tuned and tailored to the business's needs.
All righty, thank you for that. So at this time, I think that's really all the time that we have for questions today. Richard, I know you're on back-to-back demos, so I'd like to give you back just a little bit of your time to prep for the next one. That basically, that basically concludes our demo today. Again, Richard, thank you so much for your time today, and thank you everyone else for attending. Just a couple of reminders before I let you go. The on-demand link will be shared afterwards as soon as it becomes available, as well as a post-demo email with some additional resources. Feel free to browse through those resources and share them with your colleagues as well. With that being said, have a great rest of the week and enjoy the rest of your time at the summit. Thank you.
Yeah, thanks, Amy. Thanks everyone for joining. Have a good one.